If you've looked west from the Las Vegas Valley recently, you may have noticed a hazy filter hanging over the spring mountains. What looks like evening light or sunset color may in fact be something else entirely, the result of airborne particulates building throughout the day. One of the reasons why I started visually recording the colors on the mountains was that during the middle of the day, Rainbow Mountain appeared to be very vibrantly red, which it was too late for morning effects for light and too early for evening effects of light. Today, as you can see from the visuals here, the strip and the mountain range both have a lot of haze on it, a lot of particulate, which the air quality right now is being reported as good, yet that air quality seems the same visual as when the air quality was reported as moderate. This video here shows yesterday afternoon at 4 o'clock when the air quality was being reported as moderate. You can see from the effects on the trees, the effects of light on the trees, that its evening light has started. There's softer, more classic painting look to the trees. But you can also see there's a heavy particulate in the air, and that's exactly what it looks like today, especially down at the strip, but also right behind the shopping centers that are nearby 89117. It looks the same as this photo. The same thing is happening today as far as certain elements around my apartment complex being more vibrant, like the plant life has a lot more red hue to it than ordinarily, like these plants right here, and there's some flowers that I recorded that also show they're extraordinarily vibrant today because of the particulate in the air. There's a lot of red hue in all of the plant life today, and even certain plant life that is ordinarily blooming and fairly vibrant, like this right here, it still is far more vibrant than ordinary because of the particulate in the air. Have you ever wondered why the sky turns brilliant orange and red during sunrise and sunset, but stays a softer blue in the middle of the day? Tonight, we're breaking down the science behind those colorful skies and what it has to do with something called Mie Scattering. Let's start with the basics. When sunlight enters Earth's atmosphere, it hits particles like oxygen, nitrogen, water vapor, and dust. How that light scatters depends on the size of those particles. During the day, when the sun is high, shorter blue wavelengths scatter in all directions by tiny air molecules. This is called Rayleigh scattering, and it's why the sky appears blue. But when the sun is low on the horizon, like during morning and evening, its light has to travel through more of the atmosphere. That longer path filters out blue light and lets the reds and oranges shine through. Now here's where Mie scattering comes in. This happens when sunlight hits larger particles like smoke, dust, and water droplets. Instead of scattering blue light more than red, Mie scattering affects all wavelengths more equally. That leads to hazier, whiter, or even milky-looking skies. If you've ever seen a pale or washed out sunset during wildfire season, or a white glare in humid or dusty weather, that's Mie scattering in action. So while those fiery skies at dawn and dusk are mostly thanks to Rayleigh scattering and the sun's low angle, Mie scattering plays a different role, often muting those colors when there's more haze or pollution in the air. Photographers and filmmakers often talk about the unique lighting effects of morning and evening light. In the morning, light is cool and soft, shadows are gentle, and the air is typically clear, ideal for capturing crisp detail and calm moods. In the evening, the sun casts warmer, richer tones, shadows grow longer, and the landscape takes on a dramatic golden glow. These shifts aren't just aesthetic, they influence mood, tone, and even scientific observation. Understanding these light effects helps separate natural beauty from atmospheric distortion, especially in places like Rainbow Mountain where color comes alive at the edge of day.